Alright guys, go ahead and get out a sheet of paper so you can take some notes over this stuff. We're going to start with defining bisects and midpoints. So, a point that divides a segment into two congruent segments is referred to as a bisector. Okay, and the bisection point is called the midpoint. Okay, so I do want to give you a non-example and I want to clarify something. You can't have a bisector of a ray. Okay, a ray goes on forever in one direction. So in this case, right, that definitely couldn't be a midpoint. Okay, and similar to a ray, a line also could not have a midpoint because a line goes on forever in both directions. So anytime we're talking about a midpoint, it's going to have to be on a segment because it just wouldn't be possible if it were on anything else. Okay, and if it is the midpoint, then we would have to indicate that with symbols. So I could put a single tick and a single tick to indicate that X is the midpoint in this example. All right, so let's look at two questions involving this. Okay, if segment XY bisects segment AC at point B, what conclusion can we draw? Well, let's go ahead and see if we can just sketch out a picture of this situation. So we have segment XY. Okay, and this is bisecting segment AC. So AC is the one that's being cut in half. Here's A, here's C, and it's being cut in half at point B. Okay, and I'm going to indicate this with a single tick mark and a single tick mark. So the conclusion that we're drawing by definition of midpoint, okay, is that AB, segment AB, is congruent to segment BC. Okay, so this is a conclusion that you can draw anytime you have a midpoint, the two congruent pieces, and that just goes back to the definition of a bisector or of a midpoint. Okay, let's take a look at this one. If D is the midpoint of segment FE, what conclusions can we draw? Well, let's see if we can just sketch out a diagram. Okay, here's F, here's E. Okay, if D is the midpoint, I could place that here, but again, I need to indicate this with symbols, so I'm going to put a single tick mark and a single tick mark. Okay, so the conclusion that we are going to draw is that FD, okay, has to be congruent to DE, and that's just by definition of midpoint. All right, let's look at the next vocabulary word. Okay, now we're going to talk about trisection points or trisecting points. Let's just get down the definition first. Okay, so it's 2 points that divide a segment into 3 congruent segments. Okay, those segments are trisecting the segment. The 2 points at which the segment's divided, those are actually called the trisection points, so we'll look at that vocab word in these examples below. Okay, pause the video if you need to at any time. So we have right here, if segment AR is congruent to segment RS and is congruent to segment SC, okay, what conclusions can we draw about this picture? So first conclusion, or first thing I'm going to do is I'm going to add just markings to this picture to indicate the statement. I'm going to put a single tick mark on all of those segments to indicate what they're stating right here. Okay, so the conclusion that we can draw on this picture is that R and S, okay, are considered trisection points of AC. Okay, or you could also turn that statement around a little bit differently. You could say that AC is trisected by points R and S. Okay, let's look at this example right here. If E and F are trisection points of DG, okay, so this entire segment D to G, what conclusion can we draw? So if those are trisection points, okay, that means that those segments are congruent. So let's just turn that into a statement. Okay, segment DE is congruent to segment EF, which is congruent to segment FG. Okay. All right, and let's go to that next set of vocab words, the last set of vocab words for the day. Okay, and so we've been talking about bisecting segments and trisecting segments, and now we're going to talk about bisecting angles and trisecting angles. So let's get down the definition of an angle bisector. Okay, and that ray that's dividing it or bisecting it, that's actually called the bisector of the angle. So we'll illustrate that in the two examples below. Okay, so get that definition in. It's a ray that divides an angle into congruent angles. Okay, that's called a bisector. So if I have, let's state that if angle ABD is congruent to angle DBC. Okay, let's look at the picture that I'm talking about. So ABD and angle DBC. Okay, we want to know if these angles are congruent to each other. Okay, what conclusion can we make about this picture? Well, we could conclude then ray BD is the bisector of the angle. Okay, let's look at another example. Let me give you a picture. Okay, and this is angle 1 and that's angle 2. So if we are told that angle NOP is congruent to angle POR and ray OQ, okay, bisects angle POR, okay, then what can we conclude? So let's think about this for just a second. So NOP is congruent to POR, so I could put a single arc here and a single arc here. And ray OQ bisects angle POR, so not only is this one congruent to this one, okay, but that one's congruent to that one. Okay, then what conclusion can we make? Okay, then we're concluding that ray OP, okay, is the bisector of angle NOR. Okay. And then let's take a look at an angle trisector. That's our last vocabulary word of the day. Okay, I'm going to pause this video. I'm going to make the second part of this video is going to include angle trisectors and also the practice questions.